So we do our chi-square statistic. So we do chi-square is equal to the sum of all of our observed minus our expected squared all over our expected. And if we work this out, we find out that this looks like this. 10 minus 10.35 squared all over 10.35. When you have small numbers, make sure you show all of them, like I would say 5 or less. Show them all. If you have more than 5, you can do the plus dot 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 and then do the last one to show them the pattern. But show them a minimum of 3, and if it's 5, I probably would go with all of them. Plus 8 minus 7.65 squared all over 7.65 plus 13 minus 12.65 squared over 12.65 plus the last one was 9 minus 935 squared all over 935. And when I calculate this, I get my chi-square is going to be 0.051. Wow, that seems very small. Strange. What that means for me, if that's my chi-square, I have to look at how many degrees of freedom I have. Remember, that means you're going to be taking the row minus 1 times the column minus 1. The rows were 2, the columns were 2. 2 minus 1 is 1 in both cases, so the degrees of freedom is 1, which I'm not really a big fan of, but whatever. So degrees of freedom equals 2 minus 1 times 2 minus 1, which is 1. So as you do your chi-square, remember that you're looking for your p-value. Don't just write down p, because p means probability, so you have to be careful, because we often talk about the probability of your z-score being something. So talk about your p-value, and that's equal to chi-CDF of 0.051, 99, comma 1. And I get a p-value of 0.821 when I do this. Yeah, that's kind of ridiculous. So as we talk about this, this is one of those cases where you're going to say, oh, it makes me so frustrated. Our sample result for one. Oops. I love this stuff. Or one more extreme.
Can we get a T-shirt for the class?
We should get a T-shirt, you guys, and say we are more extreme. Or one more extreme would occur. 82.1% of the time if HO is true. Since our p-value of 0.821 is greater than alpha, which was equal to 0.05, we fail to reject HO. That is, we don't have enough statistical evidence to say there is an association between gender and allergies. So our null hypothesis was that there is no association, and we didn't provide any evidence to say that there is. All right. In this one, we want to know whether boys and girls get in trouble more often in school. That's definitely obvious to me. Below is a table documenting the frequency. Aaron, that's on video. Of boys and girls who got in trouble at school. Based on our results, at the 5% significance level, I'll kick Aaron in the head. H.O. Aaron.
Why do you keep saying my name?
You sound.
Oh.
There is no. See, that wasn't even recorded. Association between gender and being in trouble in school. And as always, our alternative is the same thing, but there is. So we'll say there is an association, ... All right. ... Remember, on the test, don't do ... But so your hands don't cramp up. For now, do it. Next. We will do a chi-square test for association / independence. Ran out of room. At alpha equal to 0.05, they told us. We have a random sample of, is it 237, right?
Yeah.
237 students. We will assume there are more than 2,370 students. And this is saying, of course, that the population is at least 10 times the sample. So we have independence. Sorry, just kind of scribbling now. We should look for the large sample counts, so large sample sizes. It's funny how they call them large when they're talking about the expected counts being 5. So as we look at our expected counts, no, that's not going to give the color, sorry. We could do our expected counts. So we have the boys and the girls, thank you. And then trouble and not trouble. Oh, not I.
Yeah.
Trouble and not in trouble. So for boys in trouble, 40.97. For not in trouble, 70.03. Girls in trouble, 42.03. Ooh. Girls not in trouble, 77.93. No, not right. Oh, thank you. 76.03. Did I say 76 or did I say 70?
70.
Sorry, 76.03. That is correct. Thank you. Did I get the rest of them right? I think I did. Since all counts are greater than or equal to 5, we're We're good to go. I'm not going to say since. I'm going to say all counts are greater than 5. Good enough. All right, let's talk about our chi-square. So the chi-square, how many things we have? We have 4 again. I'm going to show them all again. So I have the sum of O minus E squared all over E. If I do this, I'm going to have from the first one 46 minus 40.97 squared all over 40.97 plus 71 minus 76.03 squared all over 76.03. And then down below for the girls, we have 37 minus 42.03 squared all over 42.03. And then the last part, 83 minus 7793 squared all over 77.93. When you work this out, your chi-square ends up being 1.88. When you try to find your p-value, remember to write out the words p-value or phrase p-value. That's going to be equal to chi-CDF 1.88 comma 99 comma, how many degrees of freedom? 1 again. Super exciting. And we get a p-value of 0.1703. Remember, you have to be accurate to at least 3 decimal places. So we say our sampling distribution, or our sampling result, or one more extreme, would occur 17.03% of the time if the null hypothesis was true. Since our p-value of 0.1703 is greater than our alpha of 0.05, we do not have enough evidence to say that there is an association between gender and getting in trouble at school, but we all know that's bogus. Aaron White proves it.